Hello. Today we are going to talk about antiderivatives, section 4.10. So what does this definition say? If capital F is an antiderivative of little f, then the derivative of capital F equals little f. And then in our theorem, we talk about the most general antiderivative. The way we get that is adding the constant c. So let's just look at an example and try to make sense of this. For a, capital F is the function whose derivative is 6x to the 5th power. So I'm going to claim that's x to the 6th, and then I'm going to add my arbitrary constant, so to make it the most general antiderivative. Now, we can check this. To be an antiderivative, it says that f prime, capital F prime of x, has to equal little f of x. Is that true? Well, if we take the derivative of this function, we would get 6x to the 5th. The derivative of c is just 0. So yes, this is true. Okay, so look at b. We want to find the function capital G, whose derivative is 1 over 2 times the square root of x. And you all know by now what that is. If you're unsure of your answer, you can always check it. What is the derivative of capital G? Well, that's 1 over 2 times the square root of x plus 0, because the derivative of a constant term is 0. Capital H, well, what function has it as a derivative negative sine x? That is the cosine. And we just add plus c. Capital K is the sine, because the derivative of the sine is the cosine. And here's another F. For E, what function has as its derivative e to the x? Well, that's just e to the x plus c. Okay, so we need some notation and vocabulary. So this symbol looks sort of like an S. That is called the integral sign. Little f is called the integrand. And dx is the variable of integration. Now that for us won't be complicated. We're only dealing with one variable, but when you get to calculus 3, you have functions of 2 variables. So you sometimes want to know which one are you integrating with respect to. Now, also in here are some instructions. This tells me to integrate f. Integrate. The act of finding the antiderivative is called integration. What this also says is find the most general antiderivative of f. And this expression gets a special name. It's called an indefinite integral? If it exists, it is a function. If it exists, it will be capital F of x plus c. So lots of little vocabulary there, but let's see how it goes. Okay, so this is the same, these are the same problems as in example 1, only now I've used the notation to tell you what to do. This just says find the most general antiderivative of this, the integrand. And we know that this is x to the 6th plus c. Here, for b, we just have square root of x plus c. For part c, we know this is cosine x plus c. D is sine x plus c. And e is e to the x plus c. So this was asking exactly the same question as in example 1 here. Find the most general antiderivative. We just did it in a different way with different notation. So these rules or formulas for finding antiderivatives, really the only one you need to memorize is number 1. We will need these in the homework, but you don't need to memorize those because we will learn another way to evaluate the indefinite integral of trig functions. But let's look at the power rule. What this says is the antiderivative of x raised to some power, as long as it's not -1, the first thing we do is increase the power by 1. And the second thing we do is divide by the new exponent. What this does effectively is undo the power rule for derivatives. Perhaps you remember, if we take the derivative of x to the n, what did we have to do? We brought down the power and multiplied by it and reduced it by 1. So this formula tells us how to find the antiderivative, how to undo the power rule for derivatives. Now, this looks like a lot of information up here, but the first rule just tells me I can bring a constant outside of the integral. And the second rule tells me I can split up a sum. Now, I have this here. We cannot separate products. We cannot separate quotients. And if you think about it for a minute, I hope that makes sense because we had special rules for finding the derivative of the product or the derivative of a quotient. Remember the product rule, the quotient rule. So we need special rules for undoing those things. Now, this is not typically how you would evaluate this indefinite integral, but I'm going to show you how we could do this using rules 1 and 2. So rule 2 says I can split this up. into two pieces. That's rule 2. Rule 1 says I can bring that constant out if I want to. I really don't want to, but maybe that's not obvious right now. And now I will apply this power rule. So I have a 6 times, what am I supposed to do? Add 1 to the power and divide by the new power. That's the first antiderivative. Plus 3 times, add 1 to this power, 2 plus 1, divided by 2 plus 1. Now, I think you can see what's going on here. I have 6x to the 6th power divided by 6 plus 3x cubed divided by 3, which is x to the 6th plus x cubed, and then I'm going to remember to add my arbitrary constant. Now, do you have to do this? No, you could do it directly from here. I could just say, oh, I see what that's going to be. That is x to the 6th plus x cubed plus c. Sometimes you can just see it. I know that that came from x to the 6th. I know this came from x cubed because when I take the derivative of these, that's what I get. Okay, so let's just try our hand at this. Now, in B, it actually is probably a good idea to bring this constant out. And now this is not exactly what I recognize. I'm thinking to myself, well, wait a minute. We know that the derivative of the square root of x is 1 over 2 times the square root of x. That's not exactly what I have. So let's do this. This is x to the negative 1/2. And now I can use my power rule. So this is equal to 5 times x to the negative 1/2 plus 1 divided by x to the negative 1/2 plus 1. And we're going to add the plus c, but I saved that for the end. So what does this really look like? Well, this would be 5 times x to the 1/2 divided by, oh dear, mistake. That was not right down there. What are we supposed to divide by? The new exponent. So the antiderivative will be 5 times, we add 1 to the exponent and divide by the new exponent. Well, this is 1/2. So this looks like 10 times the square root of x plus c. How do I know if that's correct? Well, let's check. What is the derivative of that? Well, that would be 10 over 2 times the square root of x. And what is that? 5 over the square root of x. And that is what we wanted. So that's correct. So remember, a square root is a power, even if it's in the denominator. It's a negative rational exponent, and then we can use the power rule. Now suppose you tried to use the power rule here. So you write this as x to the negative 1 dx. What would happen is you'd get x to the negative 1, add 1, divide by the new exponent plus c. And hopefully you can see there's a problem here because I end up with x to the 0 over 0 plus c, and this is nonsense. That is not correct. So that's why in our power rule we have this for n not equal negative 1. So how am I supposed to evaluate this? You are supposed to remember what function has as its derivative 1 over x. That's the natural log. So you need to know this. Now, we always use absolute value because we can only take the log of a non-negative number. So sometimes it's easy to forget these absolute value bars in the beginning, but you'll get the hang of it. Okay, D, we've already done, is just e to the x plus c. Now E is a little different. Maybe, so we go back to that table. This is what I copied for us. Tells me that the antiderivative of the cosine of k times x is 1 over k sine kx plus c. Well, what is k in this case? It's not easy to see at first. At least it's not for me. But this is what we're talking about. K equals 1/2. So this is going to equal, according to my formula, 1 over 1/2 sine of x over 2 plus c. Well, we want to simplify this. And maybe we want to check. How do we check? You take the derivative of the antiderivative and see if that does indeed give you what you are trying to find the antiderivative of. So what is the derivative of this? We can ignore the plus c because that's the derivative of c is 0. Well, let's think about this. What's the derivative of sine? That is 2 times the cosine of x over 2. Now that doesn't look quite right, but we have an inside function here, don't we? From the chain rule, I get times 1/2. So now I get cosine of x over 2. What happened to this 2? It got canceled out by that 1/2. So this is the correct antiderivative. Okay, this is a fun one, haha, that you need to know. If you look at the integrand, it's tangent squared x. And maybe we go back to that table and look. I do not see a function and a formula for tangent squared x. So this is important. You need to, anytime you see something like this, a trig function squared, ask yourself, can I use the Pythagorean identity? Well, I don't see any tangent squared x here, but suppose I divide this by cosine squared x. If I do it in one place, I better do it in every place. Now I've turned my Pythagorean identity into this. 1. This term is equivalent to 1. What is this? That's tangent squared x. And what is this? Secant squared x. Okay, now I want to solve for tangent squared x. So some people might think you have to memorize this. I don't memorize it. I memorize the Pythagorean identity, and then I turn it into whatever I need. I needed something in terms of tangent squared x. So now I can rewrite my indefinite integral as secant squared x minus 1. And I know a function who has as its derivative secant squared x, namely tangent x. What's the antiderivative of 1? Well, I hope you will agree that it is x. So the antiderivative of tangent squared x turns out to be tangent x minus x plus c. And again, let's just talk about this. The antiderivative of 1 times dx, well, that actually just looks like dx. That's going to be x plus c. Why? Well, what's the derivative of x? 1. Okay, we're going to stop here. This will be the end of part 1. And I'll do the second part very soon. So this takes lots of practice. So do the homework in the book and the homework on Canvas.